Hi everyone, this is Dr. Nak. Today we're going to learn about the rectangular coordinate system. So here is the notes that I typed out. So every section that I'm going to go over, you will see notes like this, all printed out notes. These are all the important things that you're going to have to know for that section. So let's see what we're about to learn. So number one, we're going to learn how to plot points on the rectangular coordinate system, then use the distance and midpoint formulas, then graph equations by plotting points, identifying X and Y intercepts, and we're going to learn how to graph the equation by using a graphic calculator. Before we begin, if you are not certain about simplifying the radicals and writing the interval notations, and also, if you're not familiar with absolute value properties, I highly recommend that you go over those as a review problems. Anyways, let's get started. So the first definition is the rectangular coordinate system, or we call it the Cartesian coordinate system. Okay, so let's just read together here. The rectangular coordinate system, or the Cartesian coordinate system, consists of two real number lines that intersect at a right angle. The horizontal number line is called the x-axis, and the vertical number line is called the y-axis. These two number lines define a flat surface called a plane, and each point on this plane is associated with an ordered pair of real numbers, and we express that by x, y in the parentheses. The first number is called the x-coordinate, and the second number is called the y-coordinate. The intersection of the two axes is known as the origin, which corresponds to the point 0, 0. I'm pretty sure you all are familiar with the xy plane, but it looks kind of like this. Like, you remember the graphing paper? Okay, so let's bust that graphing paper out. So the vertical line is the y-axis, and the horizontal line, we call that an x-axis. Now, where's the origin? Well, origin is nothing but the center where they intersect, and then we denote this by 0, 0. I think you're okay with this portion. Okay, so let's just move along. So we're about to learn about the distance formula and the midpoint formula, and we're going to learn about what are the x and y intercepts and how are we going to find them. Now, I'm going to write these formulas out as I go along so that we don't have to go back and forth to this page in the lecture notes. So don't worry, I will write everything out. All right, so let's talk about the distance formula. I can just easily give you the formula and says, boom, here you go. This is the distance formula. But now, since we're in pre-calculus, let's try to understand how the distance formula came from. Okay, so let me pick 2 points along the x-axis. So let me just call this point x1 and then x2. And I'm going to make 2 points here. So this coordinate here is going to be x1 and then some kind of value y1. Let's call this coordinate to be x2, y sub 2. Now let me draw a straight line through those 2 points. Okay, so now our job is to compute the distance of that line. So let me just call that distance to be d. Okay, so next step, watch what's going to happen. Let me just draw a right triangle involving those 2 points. So pretend that's a right triangle. Now let's talk about this. What's the length from here to here, right? So that's the same thing as the length from here to here, correct? So pretend that x1 is 2, and then like maybe x2 is 5, and then what's the distance from here to here? That's 5 minus 2, which is going to give us 3. Okay, so just to be on the safe side, I always want the distance to be positive. So let me just put this distance as the absolute value of x2 minus the x1. That's the distance from here to here. All right, now let's talk about the distance from here to here. Okay, so what do you think? So now we have to deal with the y-coordinates, correct? So here, the height of this is going to be y sub 2. Do you see that? Because value here, let me just go, how can I do this? Oh gosh, pretend that was a straight line. So isn't this value nothing but a y2, and this point right here is y1? That's how the x1, y1 came from and x2, y2 came from. So then let's talk about the distance now. So what is the distance from here to here? Now, it's not the same thing as the distance from y2 to y1. So here, let me just call this the distance to be y2 minus y1. All right, now we're almost there. Do you all remember the good old Pythagorean theorem, a squared plus b squared equals to c squared? So what we're going to do is we're going to do the same thing. Now, instead of a, we have absolute of x2 minus x1. Instead of b, we have absolute of y2 minus y1. So we're going to apply the Pythagorean theorem to this. Okay, so absolute of x2 minus x1. Again, there's an absolute value just to make sure that the distance is positive. So this guy here is going to play the role of a. Absolute of y2 minus y1 is going to be our b, and our distance d is just the hypotenuse of the triangle. All right, so let's follow that. So here, what we're going to get is d squared equals absolute of x squared minus x1 squared. But notice that no matter what, if I square something, right, then everything's going to become positive. I just want you to keep that in mind. And then plus y2 minus y1 squared. Now, again, this is what I was saying, that you can drop that absolute value because you're going to be squaring the quantity. So you guarantee that you're going to get a positive value regardless. So let's drop that absolute value and make that into just good old x2 minus x1 squared, and then y2 minus y1 squared. Now, taking the square root on both sides. Now, when you take the square root, you're going to get a plus or minus of the square root on the right-hand side, but since we're talking about the distance, we're only going to keep the positive part. So here, our distance is going to be x2 minus x1 squared, and then plus y2 minus y1 squared, all inside of the square root. And this is precisely the distance formula. Okay, so here it is, distance formula. The distance between 2 points, x1, y1, and x2, y2 is given by d equals square root of quantity x2 minus x1 squared plus quantity y2 minus y1 squared. All right, now let's do some examples. Let's take a look at example 1. Find the distance between -7, -4 and 2, 5. You do not draw the graph, but those of you who's more of a visual learner like me, picture always helps me. So that's the reason why I drew it, but you don't have to. Okay, so let's go. So first of all, what we're looking for is the distance of this line here. So we're going to bust out the distance formula. Ready? So the distance is given by the square root of x2 minus x1 squared plus y2 minus y1 squared, whole thing in a square root. Now this point here is given by 2, 5, and this point here is -7, -4. So you can think, it doesn't matter which one you're going to call x1 and y1, but if you're going to call this guy x1 and then x2, then corresponding values should be y2, y1. What I'm trying to say is you can call this one x2, y2 and x1, y1 if you wanted to. It doesn't matter. Your answer will be exactly the same. But let's just so that we all do it the same way. So let's just take this guy to be x1 and this is y1. And let's take this guy to be x2 and then y2. Okay, now let's follow the formula. So our distance is going to be square root of x2 minus x1. So x2 is, what is it? 2 minus, now be careful right here. It's going to be 2 minus x1, but x1 is negative, right? So you're going to have a negative minus -7. And then here you're going to square it. and then plus y2, which is 5 minus y1 is -4, so you're going to have a -4 in the parentheses, whole thing squared, just like that, and square root that. Okay, so let's take one step at a time. So this is going to be square root of, this becomes 2 plus 7 squared, right? And then plus 5 plus 4 squared, all in the square root. Okay, so then this becomes the square root of 9 squared plus another 9 squared, all in the square root. So that's going to be square root of 81 plus 81. Okay, so what is that? Square root of 162. Okay, now this is the reason why at the very beginning you're going to have to review your simplifying the radicals. So let's just do this step by step. Okay, so if you completely forgot how to simplify that, this is the easiest way for me at least. So first of all, right, you're going to take your 162 and then you're going to break that down into a product of primes. So I know for sure that that's even number, so 2 is going to go in. 2 times what is going to give us 162, that's 81. Now you can break this into a 9, 9, right? And then you can stop here if you want because you have a 9 squared. If you square root that, you're going to get a 9. But if you want to, you can even bring this to 3, 3, 3, 3. So what we just discovered is that 162 is 2 times 3 to the 4th. Okay, so then I can rewrite this as the square root of 2 times the 3 to the 4th. And then, do you remember the square root property? So the square root property says if I have something like square root of a times b, that's same thing as the square root of a times the square root of b. So you don't have to go through all the steps. I just like to do everything step by step. So here you're going to have a square root of 2 times the square root of 3 to the 4th. Now I left it as 3 to the 4th because the exponent on the 3 is even, right? And remember, what is the exponent on the square root? Square root is same thing as the power of 1/2, which means this. So if I have something like square root of x, that's same thing as, in terms of an exponent, this is x to the 1/2. So now do you see that if I have a 3 to the 4th here, I could easily divide the 4 by 2. So that's the reason why I kept it as it is. Okay, so let's just keep going. So this is going to be square root of 2. And then let me just do this step by step in case, you haven't seen this in a while. So isn't this same thing as 3 to the 4th to the 1/2? Remember, square root is something to the 1/2 the power. Now let's review the properties of exponents. So look at all those reviews. So do you remember how to do this? If I have a to the m to the nth power, you multiply the exponents. So you're going to have a to the m times n. So in this case, do you see that? I'm going to have to multiply 4 times 1/2. So what is that? 4 times 1/2 is 2. So here, what we're going to get is square root of 2 and multiplying here by 3 squared. What's 3 squared? That's 9, isn't it? So this is going to be 9 times the square root of 2. And that is going to be our final answer. Okay, so let's take a look at example 2. It says determine if -6, -4, 2, -2, and 0, 5 form the vertices of a right triangle. So here's the picture for it. Now, yeah, it kind of look like this. This right here could be right angle or not, kind of close, right? So how do we determine whether this is a right triangle or not? Think about it. How do we derive the distance formula? Wasn't it a Pythagorean theorem? That's exactly what you need to do. Does it satisfy the Pythagorean theorem? So in order to do that, do you see that we need to compute the distance of this leg, distance of this leg, and distance of this length here? Okay, so just for the notation purpose, let me just label these points. So let me just call negative 6 comma negative 4 to be a point M. And then let me just call 2 comma negative 2 to be, let's just name it point P. And then the last one, 0 comma 5, let's call that point Q. Okay, so first let's compute the distance between M and P. So let's just call that A. Okay, so A is going to be distance between M and P. Hopefully you understand the notation here. So our A is this length here. Remember, A squared plus B squared equals the C squared. That's what we're about to check. So I'm calling this length to be A, which is nothing but a distance from M to P. Okay, so I'm going to do this step by step as always. So let's just first write down the formula. So this is going to be square root of x2 minus x1 squared plus y2, that's a 2, y2 minus y1 squared, whole thing in the square root. Again, it does not matter which one you want to call it, x1, y1, and such. Okay, so in this case, what do you think? Should we call this one x1, y1, x2, y2? So let's do it that way. Okay, so here we're going to get x2, so x2 is going to be 2, and then minus x1 is negative 6, so you're going to have a negative 6, and whole thing squared, and then plus y2, y2 is going to be negative 2, and then minus y1 is negative 4 squared. All right, and whole thing being square rooted. Okay, so then here, what do we get? We're going to have a square root. So this is same thing as 2 plus 6 squared, and then plus negative 2 plus 4 squared. All right, so then this becomes the square root of 8 squared, and then plus negative 2 plus 4, that's 2, so you're going to have a 2 squared. Okay, so which is going to be, what is that? 64 plus 4, which is square root of 68. Now, what do you think? Should we practice together how to simplify this radical again, since just in case you don't remember, you know what? We're all going to do this. All right, so let's go. So as a side work, let me take out the 68 on this side. So it's even, so 2 is going to go in. So what's 68 divided by 2? Is at 34. Okay, now 2 is going to go in, and then 2 times what gives 34? 17. Great, so 68 is 2 squared, which is good because we got an even exponent, and then times by 17. Okay, so here, let me just go over here. So this is same thing as 2 squared times 17. So again, this portion here becomes the perfect squared. So what you need to do is you divide that exponent 2 by 2. Because remember, let me just do this step by step, then this is same thing as square root of 2 squared times the square root of 17. So this is same thing as 2 squared to the 1/2 power, remember? And this one is square root of 17. So this just becomes what? 2 times square root of 17. All right, so therefore square root of 68 is 2 root 17. So let me box that because we need this piece of information. Okay, I just copy and pasted the graph here. So what we just discovered is this: length from here to here is 2 square root of 17, 2 times square root of 17. All right, next let's go with the distance between P and Q. So let's call that the length B. So B is distance between point P and point Q. So again, I'm going to write down the formula, x2 minus x1 squared, and then plus y2 minus y1, whole thing squared. All right, and the square root. So again, it doesn't really matter which one you want to call x1, y1, but let's just all do it the same way. So let's just call this one x1, y1, and then x2, y2. Then what we're going to get is the square root of x2, which is 0, minus x1 is 2, squared, and then plus y2, so y2 is 5, minus y1 is negative 2, whole thing squared, and the square root. So then this becomes the square root of negative 2 squared, and then plus, what do we get? 5 plus 2 squared. So then this becomes the square root of 4 plus 7 squared. So what's 7 squared? 49. Okay, so that becomes square root of 53. And I believe 53 is a prime, so let's just leave it the way it is. All right, so here is the length for B. So what we just discovered is that length from here to here is square root of 53. All right, now let's compute the hypotenuse of that triangle. So that plays the role of C in the Pythagorean theorem. So our C is distance between M and Q. Okay, so again, it doesn't matter which one you want to call it. So should we call this one X1, Y1, and then X2, Y2? All right, so if we follow that, then you're going to have a square root of X2. Oh, I'm going to write down the formula until you memorize it. Okay, and then here you're going to have a Y2 minus Y1 squared. Whole thing in a square root. All right, now let's go. So here you're going to have, crap, which one was X2 again? X2 is, what was it, 0? Okay, so you got a 0 minus 6 squared, and then plus Y2, 5, minus Y1 is negative 4 squared. Whole thing in a square root. So this becomes the square root of just positive 6 squared, and then plus 5 plus 4 squared. So then this becomes the square root of 36, and then plus, that's going to be 9 squared, right? So 9 squared is 81. So which is going to be square root of 117. I make mistakes all the time, so please double check my algebra, but I'm going to box this for the answer. So now we have computed the our hypotenuse, which is square root of 117. Now let's not forget what we're trying to do here, right? We're trying to verify the Pythagorean theorem. So now what we need to do is we have to check. Okay, is a squared plus b squared, is that going to give us c squared? All right, let's do it. So our a is 2 square root of 17 squared, and then plus b was what? Square root of 53 squared. Now the question is that going to equal to the square root of 117 squared? Okay, so then, all right, now if you forgot the properties of exponent, do you remember this one? Okay, so if you have a, b to the n, that's a to the n times b to the n, which means that this exponent is going to be attached on the 2 and then also on the square root of 17. So then here, what we're going to get is 4 times 17, right? And then plus, now square root of 53 squared is just going to give us 53. Now the question is, is that going to give us 117? Okay, so now let's go. So what's 4 times 17 is 68. So 68 plus 53, is that going to give us 117? No, because if you add this together, what do you get? Isn't it 121? 121 does not equal to 117. So which means that M, P, and Q do not form the vertices of a right triangle, although it kind of looks like it though, isn't it? But it's not. We just verify that mathematically. Okay, so we're going to write it as, therefore, the triangle, so I should say vertices M, P, and Q do not form the vertices of a right triangle. I'm just going to write triangle like that. And here's our answer. Okay, our next topic is learning about the midpoint formula. So here, I already drew the line and M stands for the midpoint. So what do you think? Isn't it, to compute the midpoint of it, do you see that this distance has to be cut in between, right? So M must be the half of the distance. Okay, so here's the midpoint formula. It says that the midpoint of the line segment with endpoints x1, y1 and x2, y2 is given by big M equals x1 plus x2 all over 2, comma, y1 plus y2 all over 2. So please note that this is going to be the x-coordinate of the midpoint, and this is going to be the y-coordinate of the endpoint. So for the x value for the midpoint, just think of it as an average of x-coordinate, and then the y-coordinate for the midpoint is nothing but an average of y-coordinate. Okay, so let's do some examples. Example 3, find the midpoint of the line segment with endpoints P1 is square root of 7, comma, negative 3 root 5, and the second point is 2 root 7, comma, square root of 5. Don't hate because you have square root, okay? We got this. All right, so let's do it. So let's first write down the formula for the midpoint. So what do we have? We have M equals x1 plus x2 all over 2, and then comma y1 plus y2 whole thing over 2. Again, it does not matter which one you want to call it, x1 or y1, but just so that we all do it the same way. So let's call this one x1, y1, and then x2, and then y2. All right, so let's go. So this is going to be x1, which is square root of 7, and then plus 2 square root of 7 all over 2. That's the x-coordinate. And then we're going to have a negative 3 root 5, and then plus another root 5, whole thing divided by 2. Okay, so now we're going to have to simplify this all the way. So now, right here, we have square root of 7 is the like term. Now, what's the invisible number sitting in the front of the square root of 7? 1, isn't it? So this square root of 7 plus 2 square root of 7 is going to become 3 square root of 7. So here you're going to have 3 square root of 7 over 2. Now, what about for the y-coordinate? You have a negative 3 root 5 plus 1 root 5. So negative 3 plus 1 gives what? Negative 2. So here you're going to have negative 2 root 5 all over 2. Now, I could cancel out those 2, so let's just write that out. So we're going to have 3 root 7 over 2, comma, just the negative square root of 5. And that's going to be our answer. Okay, moving right along. Now, before we go over the next example, let's just review what are the solution to an equation was. So please recall that the solution to an equation is an ordered pair x comma y that when substituted into the equation makes the equation a true statement. So let's take some examples involving this. Example 4, determine if the given points are solution to the equation absolute value of x minus 3 minus y equals to 4. And let's do a few problems here. So A, let's check to see whether 1 comma negative 2 is going to be the solution to the equation. So what we need to do is we have to replace our x with 1 and then y with negative 2 to see if the equation holds. All right, so let's check. So let me just check. Okay, so here you have to ask yourself, is 1 minus 3 and then minus y is minus 2, is that going to give us a 4 back? So that's what you need to show. So let's compute the left-hand side. So the left-hand side, let me just do this step by step. 1 minus 3 is negative 2 in absolute. And then negative 2, so you're going to have a plus 2. is that going to give us a 4 back? All right, now what's the absolute value of negative 2? Yes, it is 2. So you're going to have a 2 plus 2, which is going to give us 4. So it checks. So therefore, 1 comma negative 2 is a solution to the equation. Now let's look at example B. So let's take a different ordered pair. So let's check to see if negative 2 comma negative 3 is going to be a solution to the equation. So we're going to check. So let's go. So check is the absolute of x is negative 2, right? Negative 2 minus 3, and then minus y, but the y is negative 3. Is that going to give us 4 back? Okay, so let's do this step by step. What is negative 2 minus 3? That's negative 5. And then minus 3 becomes the plus 3. So that's that going to give us 4 back? I don't think so. So this is going to be 5 plus 3. Is that going to give us 4 back? No. So here 8 does not equal to 4, which means that negative 2 comma negative 3 is not going to be a solution to the equation. Let's do one more. So let's go with C. Let's check to see whether 1 over 10 comma negative 11 over 10 is going to be a solution to the equation. Don't hate just because you see fractions. We got this. So ready? Let's check. Okay, so the question is absolute of x. So our x is 1 over 10 minus 3 in the absolute. And then minus y, so we're going to have a minus 11 over 10. Is that going to give us 4 back? Don't say no immediately just because it just doesn't look like that's going to equal to 4. It might, right? So let's go. So when you have to add or subtract fraction, you need to have a common denominator. So what will be the common denominator? That will be 10. So here, I'm just going to leave this as 1 over 10. Now I need to write 3 with the 10 on the bottom. So what we need to do is what? Multiply the top by 10 as well. So here you're going to have 30. All right, that's the one that right there. And then this becomes plus 11 over 10. So the question is that going to equal to 4? Okay, so now what is 1 over 10 minus 30 over 10? That's same thing as 1 minus 30 all over 10. So that will be absolute of negative 29 over 10, and then plus 11 over 10. Now the question is that going to equal to 4? And I'm completely running out of room. That's great. So I'm just going to go on this side. So now what? Absolute value of 29 over 10 just becomes 29 over 10, and then plus 11 over 10. Okay, now what is 29 plus 11? Isn't it 40? So we have 40 over 10, which is going to equal to 4, which is the right-hand side. So guess what? I know that it looks really ugly. However, negative 10 comma negative 11 over 10 is a solution to the equation. Okay, so let's try to look at the previous example on the graph. So here is the graph of absolute of x minus 3, and then minus y equals to 4. All I did was I just solved for y from how the equation was written on the example. So here are the 3 points that we played with. Now let me just plot where those points are going to be. So let me just plot 1 comma negative 2. So where is that? Let me change up the color. 1, so x is 1 is right here, and negative 2, so it lies on the line, doesn't it? So this is 1 comma negative 2, and which happened to be a solution. Okay, so now let's take a look at negative 2 comma negative 3. So negative 2 comma negative 3, so this is negative 3. So that point is going to be here. So this is negative 2 and then negative 3. Now notice that that point is not on the graph, and this was also not a solution. Now the next one is going to be a little difficult to plot because the numbers are really little, but let's go. So x is 1 over 10. So you're going to have to divide 1 into 10 equal pieces and take one of them. So maybe it's like right here. Then your y value is going to be negative 11 over 10. So that's same thing as negative 1 and 1/10, right? So we're going to have to go negative 1, and then you're going to go 1/10. So it's going to be really, really little. So like maybe it's like right here. So notice that, I know it's probably really difficult to see, that point also lies on the graph. So what is our conclusion? Okay, so if the ordered pair is a solution to the equation, it must lie on the graph. And if it's not a solution, it is not going to lie on the graph, which is really good to know. Gosh, Our next topic is finding the domain of a given function. I think best way to do this is by example, so let's take a look. Example 5, it says identify the set of values of x for which y is defined. Now that is called defining the domain of y equals f of x. We'll learn more about how to find the domain of a function later on in this chapter. Anyways, let's get started. Part A, y equals 2 over x minus 3. Okay, so what is the restriction here? So we got fractions going on, right? Do you remember if you're given the fraction, then the denominator or the bottom cannot be 0? Because if the bottom is 0, your expression becomes undefined. So here, our restriction is that the bottom cannot be 0, which means that x minus 3 cannot be 0. Now let's solve for x then. So adding 3 to both sides, then what are we going to get? X cannot be 3. So this is the only restriction. And if you plug it in any other values of x, let's just say like maybe 0 or 5 or 100, do you notice that the bottom is still going to become a real number? So only problem point would be x cannot be 3. Okay, so now what you need to do now is to express your domain in an interval notation. So here, let me just draw the number line. So this is towards negative infinity and infinity. So here, let's just pretend this is 3. Now, x cannot be 3, but x can be any other number. So let me put an open circle around it. Now, that indicates that 3 is not included in a set. And everything on this side and this side, if you plug any numbers on the shaded region, your function will be defined. So all you gotta do is just translate it directly below. So what is that? We're gonna have a negative infinity to 3. Now this is going to be an open parentheses. That indicates that 3 is not included. And then we're going to have a union 3 to infinity. And we call this the domain of y equals 2 over x minus 3. Okay, so let's take a look at another example. So let's take a look at something like y equals square root of x plus 11. Okay, so we got the square root is happening here. Now, every time you see the eventh root, such as square root, fourth root, sixth root, your radicand must be greater or equal to 0, which means that if you have a square root of a negative number, you're in trouble. It becomes an imaginary number, which we'll learn more about that later on. So here is the restriction. So let me write it down. Okay, so the restriction is our radicand. Sorry, radicand is the quantity that sits inside of the radical. So the restriction is that our radicand, x plus 11, must be greater or equal to 0. So subtracting 11 from both sides, that means x better be greater or equal to negative 11. All right, so this is telling you that all the values that's greater or equal to negative 11, your function will be defined. Now, if you take that something that's outside of that, then you'll get that negative quantity as your radicand, which becomes y undefined. But anyway, so let's try to express our answer in interval notation. So here it is, negative infinity, positive infinity. So let's just, this is going to be negative 11. Now x is greater or equal to. So if it's greater or equal to, then negative 11 will be included. So in that case, we put a little close bracket, and then x is greater or equal to. So you're going to have to shade this side. All right, so then let's translate it directly below. So what's our interval notation? It's going to be negative 11 closed, and then infinity open. Infinity side needs to be open all the time, and also for the negative infinity. But anyways, here's our answer. All right, so now our next topic is graphing the given equation by plotting points. So let's start doing some examples. All right, example 6, graph the equations by plotting points. So first we're given y equals square root of x plus 2. Now later on we'll learn how to graph something like this without plotting points. But for now we're going to plot the points and then graph it. So here, right, let's find the restriction first. So that way I know which value of x I can start with. So the restriction, all right, so we got the square roots going on. So do you remember what's going to happen? Yes, your radicand must be greater or equal to 0, which is x plus 2 must be greater or equal to 0. Subtracting 2 from both sides, and you're going to have x is greater or equal to negative 2. So that's the restriction. So here, x is greater or equal to negative 2. So your starting point of the graph is going to be at x equals to negative 2. And you pick some nice value for x so that you can plot the point on the graphing paper. Okay, so now what we're going to do is this. Let's make a chart. So I like to keep it clean, so I always make x and a y chart. So y is square root of x plus 2. And here we go. And we know for sure that we're going to start from x equals to negative 2. So when x is negative 2, what are we going to get? That's going to be negative 2 plus 2, so which gives us a square root of 0, which is 0, which means that we're going to be plotting negative 2 comma 0. Okay, so now let's go with the next value. Next value, so think about it. You don't want to deal with decimals or anything like that, you know? So let's pick some nice numbers for x so that your outcome, your y values are clean numbers. All right, so here, let me just take x to be negative 1. Then you're going to have negative 1 plus 2. So that's same thing as the square root of 1, which is going to be 1, right? So here, we're going to have a negative 1 comma 1. Okay. So now let's pick 0. Now notice that if I plugged it in 0 in here, your y value is going to be square root of 2. Now we need a calculator for that, so let's stay away from it. So what will be the next very nice number? Well, if I have 4 as a radicand, then square root of 4 becomes 2, doesn't it? So I would just skip it to x values to be 2 for the next term. So here, let me just write it as when x is 2, then you're going to get 2 plus 2 in a square root, which becomes the square root of 4, which is 2. Again, we get the clean, nice number. So we're going to be plotting 2 comma 2. Okay, so what's the next one? Well, if it's 3, then we're going to get square root of 5. That's another decimal. Let's not do that. What about 6? What's 6 plus 2? Square root of 7? Nah, right? And what about 7? Now, 7 plus 2 becomes 9, right? And we know that the square root of 9 is 3. So let's choose x to be 7 next. So here we're going to write it as 7. Then we got the square root of 7 plus 2, which is the square root of 9, which is 3. So we're going to be plotting, let me just go down here, 7 comma 3. Okay, I think those are enough points, so let's do it. So we starting point is negative 2 comma 0, so that's right here. All right, and then next one is x is -1, y is 1. So that will be this spot right here. And the next one is when x is 2, y is 2. So I forgot to write 1, 2, 3, 4, 5. Okay, so let me see. We got the 2 and a 2. So x is 2, y is 2. So that's at this point. And then when x is 7, y is 3. So when x is 7, y is 3. Where in the heck is that? Is that right here? All right, that looks good to me. All right, now we connect those dots. Okay, I'm not a very good graphing person, so please bear with me. So let me try to connect them in one nice smooth curve. Oh my gosh. Okay, pretend that's a smooth, nice curve. Okay, so I'm gonna put an arrow right here, indicates that graph is going. All right, so this is our answer. Let's do another example. So here we have x equals absolute value of y minus 3. Now here's the difference. Usually you're given y equals a function of x, right? But here you're given x equals a function of y. So what we need to do is this. If you want to keep it the way it is, we have to pick the y values first, then compute the corresponding x values. So here, in order to make the chart, you can keep it as x comes first, y comes second, but y is the independent variable now. So I'm just going to write it like this, y and then x, which is absolute of y minus 3. And when you make it ordered pairs, right, I'm not going to forget to flip the order. You'll see what I mean in a second. So now, where should we start from? There is no restriction for absolute value of functions. So here I can pick any values that I want. So let's go with like -2. All right, so then here you're going to have absolute of -2 minus 3, which is 2 minus 3, which is, what is that, -1. So remember, that's the x value. Okay, so then here, then we're going to get -1 as an x value and then -2 as the y value. All right, and let's take when y equals to -1, our x is going to be absolute of -1 minus 3, which is 1 minus 3, which is going to give us -2. Again, -2 is the x value. So you're going to have a -2 comma -1. All right, now let's go with the 0. So we got an absolute of 0 minus 3, which is 0 minus 3, which is -3. So you're going to have a -3 comma 0. And let's just go 1. Then you're going to have an absolute of 1 minus 3, which is just 1 minus 3. So you're going to have a -2. So we're going to be plotting -2 comma 1. And then, you know what the heck? Let's just do x equals to 2 as well. So you're going to have an absolute of 2 minus 3, which is just 2 minus 3. So that's -1. So we're going to be plotting -1 comma 2. All right, let's do the fun part. Okay, so first we're going to have to be plotting -1 comma -2. So you got an x is -1, y is -2. So that's this point here. Now, next point is -2. So when x is -2, y is -1. So that will be at this point. Okay, the next one is -3 comma 0. So we're going to have -3 comma 0s here. Then the next point is going to be x is -2, y is 1. So here it is. And then next one is, what is it? X equals to -1, y is 2. So that's over here. So every time you graph an absolute value equation, you're always going to get the shape of V. All right, so here, we'll learn more about that later. So now let me try to connect those with the straight line. Look at that beautiful straight lines. Actually, I have an app on the iPad that makes it a straight line, you know, so I got really lucky here. But anyway, so this is the graph of x equals absolute of y minus 3. Now, our next topic is this. Okay, so since I use this beautiful app that draws the straight line, and I also use the graphing paper, right? I know where the graph is going to cross the x-axis and then also where the graph is going to cross the y-axis. Now, what if I drew the graph like I usually do, like Dr. Knox style, you know? Then maybe I'm not going to hit y equals to, you know, when the y value is 3 and y value is -3. So how do we do that? How do we actually find where the graph is going to cross the x and y axis? So those are the things that we're going to be talking about next. We're going to talk about finding the x and a y-intercept. So what are they? X-intercept is where the graph touches or crosses the x-axis. And y-intercept is where the graph touches or crosses the y-axis. So looking at the graph from the previous example, where is the x-axis? I mean, not x-axis, hello. Where is the x-intercept? X-intercept is where the graph touches or crosses the x-axis. So therefore, our x-intercept is x equals to -3. Now, where are the y-intercept? Again, y-intercept is where the graph is going to touch or cross the y-axis. So that will be y equals to 3. And then y equals to -3 are the y-intercepts. So if you're given the graph, then it's easy for us to determine where the x and the y-intercepts are. But what if there is no graph? So that's what we're going to talk about next. So given an equation, to find the x-intercept, you set y equals to 0 and you solve for x. Now to find the y-intercept, you set x equals to 0 and then solve for y. Keep that in mind, then let's take a look at the next example. Example 7, find the x and a y-intercept. So let's take a look at part A, y equals square root of x plus 2. Okay, so let's first find the x-intercept. How do you find x-intercept? You set y equals to 0 and you solve for x. Okay, so let's do it. So we're going to have to set y equals to 0. So we're going to get 0 equals square root of x plus 2. Now, we're going to have to solve for x. So that means that I got to get rid of that square root. So what do? Yes, you square both sides. So here, if I square this side, then I better square this side as well. So 0 squared is just 0. And then here you're going to have x plus 2. Now subtracting 2 from both sides, then we're going to get x equals to -2. Now let's compute the y-intercept. So how do you find that? Is you're going to have to set x equals to 0 and solve for y. Okay, so in this case, we're going to get y equals the square root of 0 plus 2, which is precisely square root of 2. Now, square root of 2, you're going to get a decimal value. And I think it's approximately 1.41-ish, I think. But let me just write it as 1.41, I think. Please double check. But never give me your answer in decimals. I hate decimals. Please give your answer in exact form. Exact form meaning square root of 2. Okay, so according to our computation, our x-intercept is at x equals to -2. So that means that graph is going to either cross or touches from this point. And then our y-intercept is square root of 2, which is approximately 1.4-ish. So maybe it's right here. So if you connect those dots, oh, this graph isn't so bad. I did pretty darn good, huh? So that will be the graph. Now, I want you to notice this. This was our x-intercept, wasn't it? So when x is -2, do you see that your y value is 0? That's the reason why, in order to get a x-intercept, you set y equals to 0, and you solve for that x value. Now, over here, your y-intercept is when x is 0, isn't it? Because this point right here is x is 0, comma, and y is square root of 2, right? That's the reason why to find the y-intercept, you're going to have to set x equals to 0, and then you just solve for y. Now let's look at the next example, x equals absolute of y minus 3. So this was the equation given to us in example 6, part B. Remember, we got the shape of V facing, the mouth is opening towards the right. Okay, but anyways, let's try to find the x and a y-intercept without looking at the graph, but we know what the answer is going to be. Okay, so let's first go with the x-intercept. All right, how do we do that? You set y equals to 0 and you solve for x. Okay, so then here you're going to have x equals absolute value of 0. That looks like 101, doesn't it? This is the absolute value, sorry. And then minus 3, so which is 0 minus 3, which means that your x-intercept is going to be negative 3, as we expected. And then our y-intercept, you're going to have to set x equals to 0 and solve for y. So in this case, we're going to get 0 equals absolute value of y minus 3. Now adding 3 to both sides, then we're going to get absolute value of y is going to be positive 3. Now, if you've done the prep work for this section, you should run into the absolute value, definition of the absolute value. So please note this. Absolute value of x equals to k, by definition, when you drop that absolute value, you're going to get positive side of k and the negative side of k. So therefore, you're going to have plus or minus k. That's the definition. The reason why is this. Okay, so let's take positive k, right? So if I put positive k in absolute, your answer is k, isn't it? And then suppose you take x to be negative k. So if I replace this with the negative k, so we got an absolute value of negative k, which will still give us k. So this makes sense. But anyways, so here, if I drop that absolute value, then you're going to get y equals plus or minus 3 as we expected. So this is the way to find an x and a y-intercept without looking at the graph. But anyways, I'm going to stop here. Great job, everyone. And if you have any questions at all, please let me know. And keep up the good work, y'all.